Hello, everyone. Mr. Sutherland here. Getting ready to start our final topic here in Algebra 2 Honors that we're going to spread over the next couple of days, and that is the statistics. And so today what we're going to talk about are just some standard vocabulary terms, many of which you've worked with before. And then the next class, which is Tuesday next week because of Memorial Day, and the Thursday, we're going to work on something that's called normal distribution. But before we do that, we do have to talk about some of these vocabulary words. So today, what we're going to talk about are our measures of center and our measures of dispersion. So when I say measures of center in statistics, what I'm really doing is talking about what is a typical value of the data set. And there are three ways that we look at the typical value. And you've looked at these for many years. We look at the mean, median, or mode. And so the mean, remember, is just your average of the data set. And the symbol we use for that is X bar. And to find the mean, this hasn't changed for many years for you. You take each item. So like I have my first item plus my second item plus all the way to my last item, and I divide by the number of items that I have, and that gives us the average. The median is that number that's in the middle. So when you're calculating the data, the median, there's really, the first step is you have to order the data from smallest to largest. And then the second step, if it's an odd set of data, you just pick that middle number is the median. If it's an even set of data, you find the mean of the two middle numbers, because you'll have two numbers left as you start canceling them out, and then you find the mean of those two that are left. And then the mode is the data item that appears the most often in the data set. So mean, median, mode are two different measures of center, two ways that we can describe a typical value in a data set. A lot of times when I'm looking at your quizzes, I'll look at the median because it gets rid of outliers. Some people who scored way too high and some people who scored way too low. It gives me a better sense sometimes of where everybody's at. The other thing I look at when I'm looking at your quiz values is the standard deviation of the data set. And a standard deviation and range is part of what's called the measures of dispersion. And that's really looking at how is the data spread out? Like, is the data close together? Is the data far apart? So to find the standard deviation, which represents the spread of the data, the symbol we use is this. It's a lowercase sigma. You know, the uppercase sigma is this, which you'll use next year and in calculus quite a bit. This is the lowercase sigma. And to calculate the standard deviation, what you do is you find what are called the deviations, the sum of the deviations and average them. So the deviations is, if I take my first data point, I subtract the mean, I square it. Then I take my second data point, I subtract the mean, I square it. And I do this all the way until that last data point, and I'm finding the average of those, so I divide by n, and then I take the square root of that. And what that allows is, if I'm taking the square root of something I've squared, I'm getting those values, but I'm getting rid of negative, so I know my answer is going to be positive. The range of a data set is simply the highest value in the data set minus the lowest value of the data set. Kind of gives you an idea between the high and low temperature. Is there a wide range in temperatures or a very small range? It kind of tells you how the data is going to be spread out. So let's try these problems in an environment where we're not really focused on the calculator. Then we're going to do an example where I'm going to show you how to enter this data and put this in the calculator to find it. But I want you to be able to do both methods. So the first one, I have a data set here, and I want to know what is the mean, median, and mode. So for the mean, we'll do that first. We take and we add up all of the values in this data set. There are 12 items there. If I add those up, they add to 72. There are 12 items there, so the mean is 6. For the median, I am going to put the data in order first. So I have a 2, I have a 3, I have 1, 2, 3 4s. I have 2 5s. I have 2 6s. I have a 10 and an 11 and a 12. And I just double check by counting the numbers to make sure I have 12 numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do. And now to find the median, I start kind of canceling them in pairs, right? The 3 and the 11, the 4 and the 10, the 4 and the 6, the 4 and the 6. So I'm left with two numbers, 5 and 5. The average of those two numbers is obviously still a 5. So the median of this data set is 5. And then the mode, the value that appears most often in this data set is 4. So each situation here, in this case, we have the mean, median, mode, a typical value. We get 3 different answers. There's a time when we get those all the same, and we're gonna talk about what kind of data set that is a little bit later. But it happens when you get these that are different, but it gives you an idea what a typical value is. Sometimes you're going to use the mean, sometimes you're going to use the median, sometimes you're going to use the mode. Now, range and standard deviation. So standard deviation, we'll do that second. Let's do the range first. The range is simply the largest value, which is 12, minus the smallest value, which is 2. So we get the range to be 10. Simple as that. All right, standard deviation. I find that it's easiest to do standard deviation with a table. So I'm going to use a table here and build a table to help us find the standard deviation. So the first thing I'm going to do is I'm going to list out our x values, our data set. So we have a 2, 3, 4, 4, 4, 5, 5, 6, 6, 10, 11, and 12. Okay, make sure 4, 6, 8, 10, 12. I have all the items. So look at our formula. What do we do with every data set item? We first subtract the mean from every one of them. So that's what I'm going to do in this column. I'm going to do x minus x bar. I'm going to subtract the mean each time. So 2 minus 6 is negative 4, negative 3, right? We found the mean in the line above to be 6. So now I just keep subtracting 6 from each of these, and we get these deviations. Now, what you'll notice is if you add this column up here, all these values, they will end up adding to 0 because we found the mean, we're subtracting that from the same. Some of them are below the mean, some of them are above the mean, but the mean, I don't know if you ever learned it, is the mean is a balance point. If you draw a dot plot and you kind of put a triangle there, that's where the data is balanced at. Now, what does our formula say we're going to do with all of these deviations? Well, we square them. So the next thing I'm going to do is take these and square each of these. So 16, 9, 4, 4, 4, 1, 1, 0, 0, 16, 25, and 36. Now, what we're going to do next is we're going to add all of those up. And if I add all those up, that means I get 116. So now I can use my formula. The standard deviation is the square root of the sum of my deviation squared, which is 116, divided by how many items we have. And if you do that, you get a standard deviation of 3.109. So what that means is, and we'll talk about percentages next time with the data set, is that most of my data is within 3 units of the mean. So if my mean is 6, that means most of my data is 3 less. So I can go 3.109 less or 3.109 more. So what would that, 9.109, and then this is a little less than 3. Most of my data is going to be in those values. That tells you how data is grouped together. On its own, standard deviation doesn't always help per se unless you're comparing it to something. So a lot of times we use it to compare data sets, and that's what we're going to do in the next situation. So if we look in the next situation, I have the temperatures for Chicago and San Diego, the average temperature each month for the year. And for this, we want to find the measures of center, the range, and the standard deviation for each city. So what I'm going to do is, with this data, I'm going to show you how to do this on the calculator. So if we go to our calculator page, I'm going to put in a list and spreadsheets page. So number 4, I've got to go up, and we've always got to title the data. So this first data, I'm going to go ahead and title that Chicago. Press enter. And it's going to put the data in because I've actually pre-typed them all in. You will have to type in the data for each of these. And then the next one was San Diego. And you can't use spaces when you do these. So you just have to do it all as one word. And San Diego, I already entered that data as well. You'll notice it go bold. And when you press enter, the data won't enter, but you've got to enter the data yourself. So we have our data in. So now I'm going to put in a calculator page, and I'm going to find the mean, median, standard deviation from this data set. So I go to menu, I go to statistics, I'm going to do stat calculations, and I'm going to do one variable stats. I got to do these one at a time. So I'm going to do one list. My data, I'm going to do Chicago first. I don't need to fill in anything else. I'm going to press OK. And we get lots of information here. So notice X bar, there's my mean. So the average temperature in Chicago is 59.917 degrees. So I've got for Chicago, the average temperature is 59.917 degrees. We'll do median, we'll do mode, we'll do range, and we'll do standard deviation. Okay, if I go back to that list of data, there's my standard deviation right here. See that symbol? Standard deviation is 18.177. So I've got 18.177 degrees. The median is also in that list of information. If I go down a little bit, median is right there. The median temperature is 61.5 degrees. For the mode and the range, I just have to look at, for the range, I could look here. It can tell me, right? It tells me the maximum and the minimum. So I can subtract those pretty easily and get the range to be 52 degrees. And this actually has no mode. There's no data that appears more than once. Now, let's do the same thing for San Diego. And this is where you would use these to kind of compare the data sets and make some conclusions based on that. So I'm going to find these things again. So I have it here. I can just do menu again, stats, stat calculations, one variable stats, one list. This time I'm going to do San Diego. And now I'll scroll on up here. I get the mean to be 69.583 degrees. So 10 degrees warmer on average. The median, if I go down a little bit here, the median is 68.5. So you'll notice the median is only 7 degrees more in San Diego. The mode, if I look through my data, 65 degrees appears more than once. The range, the max is 77, the minimum is 63. So this range is only 14 degrees. And then the standard deviation of this data set is right here. It's 4.776 degrees. And that should make sense to you. Here's what that means. Look at the standard deviations. A typical month in Chicago, the temperature ranges from 18 degrees below the mean to 18 degrees above the mean. The temperatures are very spread out. We have very cold winters, we have hot summers. Whereas San Diego, it's basically 70 degrees and then it's 5 degrees cooler or 5 degrees warmer. all the time. So we use standard deviations to do some comparisons. All right, so what I would like you to do now is try the next 3 problems in the notes that assess these ideas of mean, median, and mode and range, not really standard deviation, and see how you do with these, and then I'll come back and go through each of these. All right, let's take a look at the first one. Mr. Brain scored those 5 scores on his first 5 tests. What does he need to be the mean score to be 85? Well, we know that if we add all of those up, and then we add the mysterious 6 score that we don't know. So if I take those and I add those up, I get 415 plus the mysterious score. If I divide by 6, that mean is going to be 85. So that means 415 plus x is equal to 510. Subtract 14 from both sides, and we need a 95 on the last test. For B, what score does Brian need next test in order to have a median of 85? So to do a median, I'm going to put the numbers in order. So I have a 75, a 76, an 85, an 87, and a 92. Well, right now the median is 85. So in order to keep the median to be an 85, because if I add another number, I'm going to have an even data set. I'm going to have to average the 2 numbers in the middle. If I add a number over here, the median's going to go up. If I add a number down here, the median's going to go down. So I have to just have exactly an 85, because then the median will not change from what it currently is. Number 4, find 5 numbers with a mean of 16, a median of 15, and a mode of 21, and a range of 11. So let's see how we could do this. So we have 5 numbers. Now, first thing I'm going to do is, I know the median here is 15, so I can put that at that point. I know I have a mode of 21. Well, that means I have to have more than one 21, so those have to go there. My range is 11. Well, if my largest number is 21 and my range is 11, that means my smallest number is 10. And now I just need to use the fact that the mean of the numbers is 16, kind of like we do with this problem A here. I know that 15 plus x plus 10 plus 21 plus 21 divided by 5 has to be 16. So what I end up with is that missing number is 13. So there are your 5 data values. And now the final one, there are 4 unknown numbers. So 1, 2, 3, 4. The mean of the first 2 numbers is 4. So the average of the first 2 numbers is 4. The mean of the first 3 numbers is 9. And the mean of all 4 numbers is 15. If one of the 4 numbers is 2, what are the other numbers? Well, let's make 2 this. Well, if 2 is that, we know the average of these 2 numbers has to be 4. For that to happen, then that means that this number has to be 6. Now, we know that the mean of these 3 numbers has to be 9, which means they have to add. If I have 3 numbers and the mean is 9, that means they have to add to 27. And so I have 2 and 8, which means 2 and 6 is 8, which means the missing number here is 19. And now the last number, we know that these 4 numbers all have to average to be 15, which means if I add them all up, they have to be 60, because 60 divided by 4 is 15. If I do that, my missing number is 33. So there are your 4 missing numbers. So in statistics, what we need to know from today is, how do we find mean, median, and mode? How do we find range and standard deviation and what they mean? Have a great day, guys. Take care.